Ara Valencia, and today I will be discussing about the chances of things that are likely and unlikely to happen with the help of mathematics. So our topic for today is probability. Typically in math, there are things that are always constant when you find the answers to your questions. Like for example, if we multiply 2 and 2, we always get 4. If we divide 10 by 5, we would always get 2. These answers never change, and that is what makes them certain. But in the real world, things don't always go in line with our predictions. Like if I toss this coin, I am uncertain whether it will land on heads or tails. The outcome is unpredictable or random, and this is the part where probability comes in. To comprehend it better, probability can be measured in this thing called probability line. It is a number line that ranges from 0 to 1. The probability of 0 means that there is no chance of the event to happen. It is completely impossible. The probability of 1, on the other hand, means that the event is undoubtedly going to happen. It is certain. These are the maximum possibilities of an event to occur. That is why the lowest number on the probability line is always 0, and the highest is always 1. It cannot be less likely than impossible, nor more likely than certain. In the middle, we have the probability of 1/2. This means that an event is just as likely to happen as it is to not happen. The probability of less than 1/2 means that an event is unlikely to happen, while the probability of greater than 1/2 means that the event is likely to happen. Aside from writing them this way, probability can be represented in the form of decimals and percentage. 0 is equivalent to 0.0 and 0%. 1/2 is equivalent to 0.5 and 50%. And 1 is equivalent to 1.0 or 100% chance of an event to happen. Let me explain the basic concepts we need to know, for we will be using them all throughout the lesson. First, we have the probability experiment. This is an action that has a random but specific result. Sounds contrasting, doesn't it? Let's have this coin for example. If we toss it, we do not know whether it'll land on heads or tails. So we could say that the result was randomly obtained, but we are sure that it will land on a specific face, either heads or tails. In other words, an experiment has more than one possible results. So tossing a coin is an example of probability experiment. Other examples include rolling a die, spinning a wheel, picking a card in a deck, and many more. The result of a single probability experiment are what we call outcome. The most basic outcomes are what we call sample points. We could have the tail of a coin, a 2 on a die, or a queen from a standard deck of cards as examples. A sample space is a collection of all the sample points or a collection of all the possible outcomes. In tossing a single coin, we have S is equal to HT, which stands for heads and tails. For rolling a single die, we have S is equal to 1, 2, 3, 4, 5, 6. Since a die has 6 sides. For the standard deck of cards, we have S is equal to 1, 2, 3, so on until 52. Since there is a total of 52 cards, so those 52 cards are divided into 2, half of which are 26 black cards, and the other half, which are 26 red cards. The black cards are divided into 13 spades and 13 clubs, while the red cards are divided into 13 diamonds and 13 hearts. Each kind is numbered 1 to 13, wherein the jack, queen, and king are numbered 11, 12, and 13 respectively. These are called face cards, 3 in each kind, which make them 12 in total. An event consists of one or more outcomes and is a subset of the sample space. The formula of a probability of an event is the number of outcomes in an event over the total number of outcomes in a sample space. Let's try an example. Get ready for this may be a little bit tricky. Though it's a little confusing, it is very fun to do. Let's start with the coin. Given that a coin is tossed 3 times, the first step to do is to find the total number of simple events. How do we do this? Each coin has 2 sides. It will be flipped 3 times. So we have to multiply 2 to itself 3 times. So 2 times 2 times 2 is 8. Therefore, there are 8 simple events or 8 possible outcomes of flipping a coin thrice. Under the first toss, we get heads or tails. Under the second toss, we get heads and tails too, but it will be doubled since our first toss has 2 possible outcomes already. So for each outcome, there will be a sub-outcome. That will be doubled again after the third toss. So for the events, we have the head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, and all tails. If we are being asked to get the probability of getting all heads, let us use the formula. How many events shows all heads? Just 1. So our numerator is 1. How many are the total events? They are 8. So 8 will be our denominator. So the probability of getting all heads is 1/8. If we are being asked to get the probability of getting exactly 2 tails, first, we have to count the events which has exactly 2 tails. We have 3, which will be our numerator, and our denominator will be the total number of events, which is 8. Therefore, our answer is 3/8. Next, get the probability of getting at most 2 heads. When we say at most 2, it means 2 and below. So we have 6 as our numerator and 8 as our denominator. It will become 6/8. But this is not the final answer. This can be reduced to the lowest term. To do this, we have to find a number which is divisible by both the numerator and the denominator. So 6 and 8 are both divisible by 2. And our final answer is 3/4. Last, get the probability of getting at least 2 tails. In this case, we are finding events that have 2 or more tails. We have 4 as our numerator and 8 as our denominator. This can be reduced to 1/2, which is our final answer. Next, we have the standard deck of cards. The total events are 52. If we were asked to get the probability of getting a diamond, we have 13 diamonds in a deck, so that will be our numerator. We have 52 cards in total, so that will be our denominator. 13/52 can be reduced to 1/4. Next, the question is getting non-face cards. Our face cards in total are 12, so we have to subtract it from 52. So 52 minus 12 is 40. So there are 40 non-face cards in total. That will be our numerator. Our denominator is 52, so 40/52 is equal to 10/13. Then, we have to find the probability of getting red cards. there are 26 red cards, which is our numerator, and 52 as our denominator, as always. So 26 over 52 is reduced to 1/2. Next example we have is the die. If I roll a die twice, our total number of outcomes or events is 36. How? There are 6 sides in a die, and if rolled twice, 6 multiplied by itself is 36. Since it will be hard to write the outcomes in this way, we could organize them in a table. For easier spotting, diagonal sums are seen in the table. Each line would add up to the same number. 1 plus 1 is equal to 2. 1 plus 2 and 2 plus 1 are equal to 3. 1 plus 3, 2 plus 2, and 3 plus 1 are equal to 4, and so on. If we are finding the probability of events with the sum of 4, we have to count all the events that add up to 4. We have 3 events, which will be our numerator. Our denominator is the total number of events, which is 36. So 3 over 36 could be reduced into 1 over 12. So there is 1 over 12 chance of getting the sum of 4. Next, if we are asked to get the probability of getting the sum of at least 10, we have to find all those that add up to 10 and above. So we have 6 as our numerator and 36 as our denominator. 6 over 36 is equivalent to 1 over 6. Last, we have the bag of balls. Given that the bag contains 3 yellow balls, 4 red balls, and 1 blue ball. To find the probability of getting yellow balls, we have 3 yellow balls as our numerator and 8 as our denominator, since it is the total number of balls. So 3 over 8 is the answer. Next, find the probability of getting red balls. So we have 4 as our numerator and 8 as our denominator. This can be reduced to 1/2. Finally, we have to find the probability of not getting a blue ball. So the non-blue balls are 3 yellow balls plus 4 yellow balls, which makes 7. And our denominator is 8. So the answer is 7 over 8. That ends our lesson for today. All we have to remember is the formula, because once we know it, the whole process will be easier for us to do. Also, we must be careful, especially when it comes to word problems. So that's all for today. Thank you, and I hope you enjoyed watching this video.